Hello friends, this is the first demonstration video regarding stitched image overlaying over map. Okay, so first part is the data acquisition. So here I'm using Google Earth Studio to acquire the drone images or drone video frames, capture different aspect using the drone for the same surroundings. Okay, so let's dive in. Start with Earth video. So here I'm going with quick start guide. It provides a different aspect of overview of using while capturing the drone images or drone videos. So you can see we go one by one and what experiment I've done and what things I found. That's why I rejected it for my data acquisition part that I will tell you in this video. Okay. So let's go to the Zoom tool. Click it and start. So here it started. Setting the location. So that's- so yeah. So the main issue I found here, you can see I start the starting point altitude here, okay, to make it more visible. But when I click the start video, it just captured the same frames and all frames were overlapped. There's nothing more information added while you stitching the video because after the first frame, all the frames are its sub frames, which doesn't give you a good overview of the area while stitching all the images in the video. Okay, so that's the main thing I have not considered it. I experimented with it with different frame rates to capture the videos and do stitching part. So I don't find any additional information. That's why I don't consider this tronic view for my task. Okay. So let's move it and again go to the studio. Now go to the orbital. Zoom to zoom, I describe you why I don't consider for my data acquisition part. Now let's go to the orbit. So here I also take the same location. Okay, Church Street, London. Okay, so suppose there. So as you can see, the surroundings and the angle on which it's capturing the frames. It's not ideal case for using image stitching or this kind of thing, map overlay. As you can see, you can change the radius and this kind of things. Experiment, you can do that. But I will not say that it's ideal case because I've experimented it all a lot and yeah, things kind of stuck. As you can see here. Yeah. So as you can see, no much sounding were captured. After setting certain angle, you can capture the surroundings, but that's not most suitable case, I would say, for image for generating the images for stitching. And this kind of generally dronic view used for 3D modeling, for generation 3D modeling and this kind of things of games. You can use that kind of dronic view to capture the images. But for our cases, for image evolving, this is not an ideal case. That's why I don't consider this orbital view for our data acquisition. Okay, let's go to next view. Now go to point to point. Okay, I will take the same location. So let's dive in. Church Street. Okay. Shouldn't cafe. Okay. 1 minute. Just 1 minute. So I consider this view, okay, for data acquisition point. Fly to orbit view. As you can see, you can change the path based on the location. You can extend the path, and it's very much suitable for capturing our video frames for generating the stitched images. You can see the different aspect also. Like I dropped the location from church straight to Shilan Cafe, which is not far away. As just for demonstration, I can say you can keep the distance longer and make it more suitable for your task. So this is the ideal case point to point which I used for my image generation, because you can see its camera movements are very good. It's not too much overlapping. Yeah, certain overlapping would be there because it's helping image stitching, but yeah, that's the most ideal case. So that's why I consider it as point to point for my data acquisition. Okay, so let's close it. Now I think I have done all this. Spiral. Okay, let's go to spiral also because I have experimented on that also. Church Street. Okay. So in the spiral case, again, it will be used for 3D modeling and this kind of things because the image capturing angles were entirely different. You can adjust it, but it's not the ideal case for doing that. And most of the image overlapping and frames overlapping were not there. It will always give you different aspect while capturing the video of the same location. So that's why it's not suitable for my case. Okay. So I don't consider that. So next. So I've done all these four. Let's go to point orbital. So this is exactly similar. Same, I experimented with it. Target altitude, not that much changes. Of course, it provide a broader view while increasing the radius, but while increasing the altitude also and decreasing it, it doesn't give you that acquiring things. Okay, because camera movements were still, and yeah, you can capture it, but it's require a certain tuning also. Like if I go there, set it to 5 seconds. Okay. Here you can see camera movements were fast also, and in some part the image overlapping but not that much. Okay, so that will increase the configuration time while stitching the images. Okay, because you can see the part which are coming here in this location, in this area, this were kind of slight difficult while doing stitching part as per my observation. So that's why I don't consider this also, because it's time computation time and configuration also, because you have to set it also to certain angles and then try to capture it. And even that also, that I don't find it very suitable. It's taking time also because of this regions, and this were regions for stitching because of less overlap, of course. Next, point to point done. All fours are done. Spiral, orbit, and I guess I have done with this also. Try to orbit. Let's put it. So here again you can see not the ideal case for us. Always try to do adjustment, and even if the frames were not that much overlapped, then the stitching will always fail most of the cases. So that's the main reason I don't consider this also. Okay, and I guess orbit was similar. There's nothing changes. Also spiral, same issues. 3D backgrounds. You can change its configuration, but still I'm not sure to get the images according to my overlaying task. That's why I don't consider. So yeah, these were the data acquisition part which I played around while working on these image overlaying tasks. Yeah, that's all. Thanks. Hello friends. This is the continuation of my earlier video where I described regarding my data acquisition part. Now let's dive into the some of the side process which I used for rendering the video. So after going to selecting to the point port to point drone view data acquisition, we have to go to the render button, click the render. Here you can see the all the adjustment you can do. Here you can type the name of the video which you want to use after getting, like after rendering you will get. So you can describe the name. Here you can set the frame rates, all the settings, but here I put it default because I want to do all the things locally. Okay. So here you got the JSON file, which of course describe the tone configuration file while capturing the different frames. So if you don't want it, you can set it none. But in my case, I set it to JSON. When I click the submit button, it started rendering on backend, and after a few minutes, it will give me the video. Okay. So yeah, that part it's remaining on the data acquisition, which I don't cover. So I covered it here. Okay. Okay. Let's cut down this. Okay. Leave it. Now this is the frame extraction pro. So I use this FFmpeg package for my frame extraction. Okay. So here you can see I refers to the input. Here I describing my input file. Here is the video frame. Uh, per second we are describing 1 FPS per second, means 1 second it will extract the frames. And here it save is as frame 01, frame 02, frame 03 on JPG format. Okay. So while running the CMD command on the any videos which are in local machine, you can extract the frames. Okay. So here I have the frames of my earlier video which I extracted from it's around 16 frames which I extracted from it using ffmpeg command. Okay. Now let's go to the stitching part. So approaches which I tried for stitching is two approaches. First is I tried with the SIFT features extraction model, SIFT feature matching model. So this is the code which I use. It uses two images for to stitch. First, it converted to grayscale. Then we have to initialize the detector. Then it will take the gray images and give you the descriptor and key points. Then using the CB to flame based matching using KDT algorithm, you generally find the matches and then describe the each matches in the descriptor, and you will describe all the good matches is based on the distance configuration parameters which you set here. And your top 10 matches, I am considering it to checking it. Homography, it's providing a perspective while uh, generating the matrix for that over that feature matching matrix, where it shows the all the images which are feature matched, all the two images which you want feature match. And here it generates image result image which you are basically showing it as a result. Okay. So yeah, here you just passing the two images in the directory and do the stitching. But the main issue I found that it will only consider two images at once. But here I want all the image perspective, and according to that I want to stitch it because each frame's consider having a different aspect of the images, different aspect of the area which is it's covering. So it's not possible for using Stitch and Swift algorithm to capture. It's not suitable for that kind of tasks. So I tried with this, but of course it will give me a slight blurry and not that good stitched image, which give you overall overview of that area. So of course I have to go to the stitch frame this script where you use CB to stitch matcher creator, stitch creator, where it uses its internal algorithm to stitch the images. Of course, there's some overlapping happened, but that all things that take care by this CB2 stitcher. So yeah, you just have to pass your image paths where all the images were contained, and the saving path where you want to save it. Here you are loading the images and then putting into the list, and then you are calling this stitcher, and then you start appending it, and it will give you status okay, then it will be fine. It will write the stitched image, otherwise it will be faked. Here you are describing the image path where the multiple frames of images were there with a frame 0102.png or JPG. Okay. Here you are calling the stitch function to stitch all the images. Okay. So yeah, these were the things for stitching images, okay, which we consider for our map overlaying part. Okay. Yeah, that's all for stitching. Hello friends, this is the continuation of video frame stitching. Okay. So after running this stitch frame code, which I run here. Okay, I forgot to open. This is the stitch frame code which I run. And after running this, I got an output which I saved, I guess, in my, is it stream? Yeah, this is it. So I'm getting this stitched image. As you can see, there's three times Google Earth written because these frames were overlapped and then stitched together to give us a great overview regarding that area, which is UK Church Street. You can see slight of big padding was there to make it an approximate size. Okay. Okay. So yeah, this is we got. And one more thing I forgot to mention while rendering the video, I got the video. This is the video which I used. That is point to point data which I captured through drone view and using that location UK Church Street. Okay. And here is the JSON file which I get. It have the name, width, height of each frame rates that describe 30 frames per second, and durations of the video, and all the amplitude, latitude informations, points of the informations are captured here in the JSON file. Okay. So one of the three approaches I tried to get an understanding, like I uses simply the JSON file and all the frames. Okay. And basically, my main idea is to get the projection, widthwise projection of the all the coordinates in the stitched image. Okay. So here I am checking the all the stitching folders is present or not. Here I am reading the diff file. If not found, it will not give me an error, and it will calculate the stitch width and height. Here, this is longitude and latitude projection, which I got from Stack Overflow. I listed it, use it, and yeah, here's the projected coordinate frames, which I want to capture from my all the 16 frames. Okay. So here I'm just describing it for loop by removing the underscore and capturing the names, and then I am checking it in the frames. It's really a flawed idea because in JSON file, all frames are catch of 30 frames per second, and the naming conventions are like that. So of course, it's completely flawed idea because namings are completely different. But here I'm saving it the frames sequentially, which will not match with the parameters of the frames which are given to the JSON file. So yeah, I tried this and do the transform projections and appendix. Okay, now I normalize it. The metadata normalized metadata of width and height I was given, and this was a horizontal stitching which I done just to get an overview how this images were staged or this kind of things. I wanted to understand that. So here I am performing some projected point projections using the pixel coordinates. Okay. Here I am describing what are the total projected coordinates which we are getting through pixels. And here we created the stitch image copies and then try to project this using this pixel points, and we are basically trying to project it on geo inferencing. So yeah, that complete idea is completely flawed. I am not getting that good overview of the image, put any results or anything. It's a get an understanding how this thing works. But yeah, I tried with the stretched image to get an understanding, but it gave me just a straight line describing the horizontal vertical projections of the points of the frames which I use for stitching and build this entire over. Okay, not that helpful, but just to understand it, I experimented with it. It's a very flawed idea. So yeah, going on, I get the my stretched image here. This the here, yeah, in the stretched image. So yeah, I tried with two basic service, that is QGIS and Google Earth. First, I go with the QGIS. So I tried with QGIS to install the geoinferencing plugin and this thing, but I don't know, somehow it will not work in my case. It's describing here that it installed the geoinferencing plugin, but I'm unable to find that. And yeah, it's working is quite different for me. It's not very much like a user-friendly UI. So I experimented a lot to get an idea and overview how this thing works, going through multiple videos. But yeah, but some says there's street map that you have to import and do the working of it. But after a while working with it, I'm not able to figure out how to perform overlaying using this QGIS tool. So I switched to Google Earth. That is simple and efficient way to do this overlaying part. Yeah, let's start with the Google Earth. Okay, here it's saying subjects. Okay, just close it. Here I typed search street street street. Okay, okay. So track the location. I'd see search it. So here it goes to the image street. Okay. Now it's simple and straightforward. How many image overlay? Okay. Just go to here, add for option, go to the image overlay, then browse the image which you want to overlay. Here I'm going to there institution and then go to article this and stage image. Okay. So this is it. Set it okay. So here as you can see, this is the thinner line which shows me the stretched image which I'm pasting here. Okay. The entire overview of the church street. Okay. And here you can see the thin lines which show the stitched image here. Okay. This line. Okay. So yeah, this is the simple image overlaying which I used. Here you can save it as an image. Okay. Hold it here, where is it? Save it. So it takes time because it's quite a bit heavy application. So here I saved the image earlier. You can see that this line shows the overlaid image. Here I generated this image, basically capturing the overlaid image. Here you can see this box entirely shows my stretched image on the entire map, and this was the complete Google Earth map. So yeah, these were the complete overlay project. Yeah, that's all. Thanks.